I go through the class times problems. They're a help for you. I feature these heavily on the test. These are the things I think that you need to know. I'm going to show you the answers for most of them, and however, for some of them I'll go through the thought process behind it. For number one, you are given a amount of gas that's released into the atmosphere every day. And they tell you every day that 5 tons of this gas are released. And of that gas, 5% of it is the sulfur dioxide. And they want to know how much sulfur dioxide is released in tons per week. So we're just going to use a little dimensional analysis. Starting with our 5 tons of gas per day, we convert that using a conversion factor that we know 1 week is 7 days. And we make sure that we have days on the bottom and days on the top, so those two cancel out, and it leaves us with week. So we know that 35 tons of gas are released in 1 week. Then we're going to make use of our percentage that we know of 100 units of gas, and it doesn't matter what the units are, in this case it's tons. Of that 100 tons, 5 tons of it will be the sulfur dioxide. So I use that as a conversion factor as well, and when I multiply everything on the top and divide by everything on the bottom, I come out with 1.75 tons of sulfur dioxide are emitted in 1 week. The second problem is a comparison. They want to know what mass of mercury will occupy the same volume as 45 grams of chloroform, and they give the density of both these liquids. The first step is to take the chloroform. We know its density and we know its mass. We have to figure out what space it will occupy, and that will be 30 milliliters. So once we've used the chloroform, we move on to the other part of the problem, and that's the part that they've asked us. What mass of mercury will occupy the volume of chloroform? We've determined the volume of chloroform is 30 milliliters. Using our density formula, we figured out that 408 grams of mercury will occupy the same volume as the chloroform. We do note that mercury is much, much more dense than chloroform. Problems 3 and 4 are you manipulating scientific notation and using rounding techniques. So I'll leave you to look at those and make sure that you are getting the right answers. Question 5 has you then using your significant figures and or rounding skills in mathematical operations. Please recall the problem most kids have is that the significant figure rules are different depending on the mathematical operation you are performing. If you are adding or subtracting, you match the least number of decimals in your problem. So for problem J, we see 97.381 has the least number of decimals. That controls the number of decimals that will be reported out in your answer. Same thing for K in subtraction. Now in 6, we have some mixed problems. Please remember your orders of operation. Do them in the orders that you're supposed to, and then correct your number of significant figures. All right, going on to the second page, we have one more problem to do, and then coming to problem number 7, which is a very typical AP question. I believe it's been on the last, 8-10 years. The problem is not so much a density problem as it is a significant figure problem. It is a very simple density problem. You need to determine the volume by subtraction. When you do that subtraction problem, you match the least number of decimals, which is 1. So you report on an answer of 8.9 mLs. That 8.9 mLs then goes into the density formula, and since you're doing dividing, you then match the least number of significant figures. Your calculator will burp out a number that has a number of digits. You may only report 2 significant figures because 8.9 has 2 significant figures. Then we have some questions about separation techniques. And then we go to problem 10, which is a variation on problem 7.